Fellow classmates and Dr. Frisch, this is Bennett and I's presentation on power adapters and chargers, how they work, what they're used for, and why they're just generally awesome.
So, for a quick outline, charging a battery requires stable DC current, unlike the AC current that comes out of the wall. Batteries also require much less voltage than comes out of the wall, often between 5 and 12 volts. So, from the wall, power goes through a few steps. First, through a transformer, which decreases the voltage to whatever level is required. After that, a rectifier is used to convert from AC to DC current. Next is a capacitive filter, which steadies out some of this variable voltage. And last is a regulator, which steadies the voltage further so that sensitive electronics are not damaged by surging voltage. The regulator, power is sent to the device where it can be used to charge batteries.
Okay, so the first step that we're going to talk about is the transformer. This is the first step where electricity goes after it comes out of the wall. So we talked about transformers a little bit in class, so this will just be a brief review. There are two main types of transformers. There's step-up and step-down transformers. And the difference between these depends on which side the electricity flows into. If you look at the picture in the bottom, the primary side has more coils than the secondary side. So if electricity flows into the primary side, it will be a step down in the secondary side and have a lower current. So, yeah, the properties depend on the number of coils on either side of the transformer. One interesting thing to note is that this only works with AC current because the current from one side, the magnetic field created by it, will induce a current in the other side of the transformer.
Next up is a rectifier, and the rectifier is just a fancy word for an object that converts AC current to DC. Alternating current varies with time, first becoming positive, then switching to negative, and back to positive again. A battery requires DC current to charge, so we need to convert the AC to DC. There are two main ways to do this. These two ways are called half-wave and full-wave rectifiers. Half-wave rectifiers use a single diode to capture the positive side of the AC wave. A diode is just a one-way valve for electricity. It lets electricity flow in one direction but not the other. A half-wave rectifier uses one diode and captures just the positive part of the AC current. This leads to voltage spikes with long periods of nothing in between. A full-wave rectifier uses four diodes arranged to not only capture the positive part of the wave, but flip the negative parts so that they produce a positive DC voltage.
Okay, the next step in the process is the capacitive filter. So when the current comes out of the rectifier, that consists of very large peaks followed by areas where there isn't very much charge. So the capacitive filter is essentially just a very large capacitor that is used to even out the voltage variation from the rectifier. So as you see the peaks on the graphs below, that charges up the capacitor, and over time it slowly discharges so that it maintains a more constant current than it would if it was just the two waves that you see down there.
Last up is the voltage regulator. And in a regulator, voltage passes through a variable resistor on its way to do some work. After the resistor is a special circuit that senses the voltage and controls this resistor. When it senses the voltage is not correct, it varies the resistance either up or down to adjust for the voltage. There are a couple downsides to this. The first is that it is not the most efficient design, as the resistor is always consuming some of the electricity produced. Second, there is a slight lag between the controller sensing an incorrect voltage and the resistor adjusting for it. This time may be decreased, but is never zero, which leads to just still subtle changes in the voltage produced.
Okay, so in conclusion, electricity comes out of the mysterious plug in the wall. It travels through the cord to the transformer, where the voltage is stepped down. It then goes to the rectifier, which converts it to all positive voltages. The capacitive filter comes next, and this is used to even out and create a steady and stable current that comes out of the device. And lastly, you have the regulator, which further works to tweak and stable out the voltage that is produced. And next, it can just go straight into your device, whichever one you want to power or charge. And because it is now DC current, it can be used to safely charge and power those. Thanks for watching. Here are our sources.